I'm going to solve the problem 1117, which is said 9 meters beam is hinged to a 4 meter to a wall 4 meters above the hinge. This is a hinge at this point H, and this is the cable, and it's 5 meters long, and it's proved that the strength of this cable it's 1000 newtons. If the tension is bigger than that, the cable will break. So what are we gonna use are these formulas for equilibrium, because the system is in equilibrium. So the addition of the forces on x is equal to 0, as well as y on y is equal to 0, and the addition of all the torques is equal to 0. Note that the point H is the pivot point for all the torques. So the part 8 is asking us to find what is the heaviest beam that this cable can support with this given configuration. So first part, we need to find what are the distances. So this distance D is going to be fine like this. This is a triangle rectangle. This is 5, this is 4, and this is the distance D. And D is equal to the square root of 5 squared minus 4 squared, which is equal to 3 meters. Then we need to find the center mass for the beam. The distance over here, which is the center mass, is equal to the whole 9 meters of the beam divided by 2, and this is equal to 4.5. Then the other thing that we have to find is the angle made by the tension and the beam, which is we find it with sine of theta is equal to 4/5, which gives us theta equals to 53.1 degrees. Then, as we know that the pivot point is H, we have to find the sum of the torques on H is equals to 0. And the cable make a counterclockwise torque in this direction, which is positive direction. So we know that this is going to be this tension times sine of theta in the positive direction, and times D minus the weight of the beam times Cm, and this is going to be equal to 0, where the weight of the beam is going to be equal to tension sine of theta times distance divided by Cm, and this is going to be equal to 1000 times sine of 53.1 times 3 divided by 4.5. So the weight of the beam is equal to 533 newtons, but we need to know the mass of the beam, which is equal to the newtons divided by 9.8, and this is equal to 54.4 kilograms. Okay, this is for part A. For part B, it says find the horizontal component of the force the hinge exerts on the beam, which is this. This is the beam, this is the tension, this is the hinge. So this is the horizontal component. Well, let's call it H of H. So H of H, we're gonna find it with this formula. The summation of forces on x direction equals to 0, when H of H minus T cosine of theta is equal to 0. So H of H is equal to 1000, which is the tension, times cosine of 53.1, and this is equal to 600 newtons. And for the part C, we have been asked to find the vertical component of the force H, and we're gonna find it with this formula. We are gonna use the summation of forces on y direction equals to 0, and the forces are the T sine of theta, which is this force over here, minus the web of the beam minus the vertical component of the hinge is equals to 0, which is giving us the vertical component of the hinge is equal to T sine of theta minus the weight of the beam, and this is equal to 1,000 newtons times sine of 53.1 minus 533 newtons, which is the weight of the beam, and this giving us the vertical component equals to 267 newtons. And this is going to be negative because these over here is a hinge, and the vertical component is going in a clockwise direction, which means negative. So the answer is going to be H of B is equal to negative 267 newtons. And that's the last answer for this problem. Thank you.